Figure 4 shows a right circular cylindrical rod which is expanding as it is heated. At time t seconds, the radius of the rod is x centimetres and the length of the rod is 6x centimetres. Given that the cross-sectional area of the rod is increasing at a constant rate of pi over 20 centimetres squared per second, find the rate of increase of the volume of the rod when x equals 2. Right, let me write down some properties of this rod, of this cylinder. I can say that the cross-sectional area, the cross-section is the circle, which will be pi times the radius, which in this case is x, squared. I could also use this to write down an expression for the volume. I could say that the volume of this prism is the cross-sectional area times the length, which would simplify to be 6 pi x cubed. So I've got a couple of expressions there for the area and the volume with respect to x. Now, I could, if I wanted to, differentiate each of these with respect to x. We're going to need to do this shortly. So differentiating the pi x squared with respect to x will give 2 pi x. And differentiating the volume with respect to x will give 18 pi x squared. Right, let's have another look at this question. Given that the cross-sectional area of the rod is increasing at a constant rate, so that's telling me that dA by dt, the rate of change of the cross-sectional area, is equal to pi over 20. So I now need to find the rate of increase of the volume of the rod when x equals 2. So I want to find dV by dt, the rate of increase of the volume. So I could connect these rates of change together. I could say that dV by dx times dx by dt. I know dV by dx. I don't at the moment know what dx by dt is, but I can find it out because I can say that dA by dt is the same thing as dA by dx all I've done there is I've connected the rates of change with the dA by dt equation. And I know that the dA by dx is the 2 pi x. So that is going to allow me to work out the dx by dt, which I can then use in the other equation. So, when x equals 2, dA by dx is 2 pi times 2, so 4 pi. So if I use that down here, I find that 4 pi times dx by dt is equal to pi over 20. The pi's cancel out. Divide both sides by 4, and I find that dx by dt is 1 over 80. So I can now substitute that in here. So dV by dt equals dV by dx. So let's work that out. So when x equals 2, substituting that in here, I find that dV by dx is equal to 18 pi times 4, which is 72 pi. So dv by dx is 72 pi. dx by dt is the 1 over 80. And that's going to simplify to be 9 pi over 10. And that is in the form required. So this is my answer.